Hey, welcome. Before we dive in, do me a huge favor and just smash those like and subscribe buttons down there for @BrandTechAuth. It really helps us out. Okay, let's get right to it, because today we need to talk about a huge and honestly kind of scary problem sitting right at the heart of artificial intelligence. I mean, it sounds like the beginning of a sci-fi movie, doesn't it? But it's a real question we are facing right now. Why does ChatGPT sometimes just make stuff up? Hallucinate? Why do other AI models get these weirdly specific and sometimes aggressive political views? We've built these unbelievably powerful digital minds, but it turns out there's a critical flaw in how they're designed. And that flaw has a name: the AI black box problem. And you could argue it is the single biggest challenge facing the entire industry today. See, we can see what goes in and we can see what comes out, but the why in the middle, it's a total mystery. And as these systems get more and more powerful and we start plugging them into everything, well, letting a mysterious black box make important decisions for us is a risk we probably can't afford to take. But what if we could crack that box wide open? Or even better, what if we could build the box with totally clear glass walls right from the start? Well, that is the mission of a San Francisco startup called Guide Labs. It was founded by a couple of MIT and Y Combinator alums, Julius Adebayo and Aya Abdelsalam Ismail, and they have just released a new AI model they think changes literally everything. Now look, this isn't just some side project somebody cooked up in a garage. Guide Labs is a graduate of the legendary Y Combinator Accelerator. They've already pulled in $9 million in seed funding, so they're tackling this problem with a super serious scientific approach, and their first big drop is an open-source model called Stirling 8B. And here it is. This is their breakthrough claim, the part that sounds like it's straight out of science fiction. They are saying that with their model, every single word, every token it generates can be traced back to the exact piece of source material in its training data. No more mystery, no more guessing games, just a clear, verifiable paper trail for every single piece of information. The obvious question is, how in the world did they pull that off? To really get what they did, you have to understand their philosophy, which is completely different from how pretty much everyone else is looking at this. They didn't just tweak the old method, they basically threw out the entire playbook and started over. Okay, so check out this analogy because it makes so much sense. The old way of doing things is like neuroscience. You take a finished, super complex AI, the black box, and you poke and prod it, running tests, trying to guess how it thinks. It's reactive, it's messy, it's uncertain. Guide Labs, on the other hand, took an engineering approach. Instead of trying to study a finished brain, they designed the brain to be understandable from day one, building transparency right into its architecture. So how does this engineering approach actually work in practice? Well, it all comes down to something they call a concept layer. Before the AI even starts its training, all the data is meticulously labeled and sorted into clear categories. Then, this special concept layer gets inserted right into the model's core. You can think of it like a super detailed map or an index, creating a permanent traceable link between anything the AI says and the specific data it came from. It's not an afterthought. It's transparency by design. Now, a totally fair question is, doesn't all this pre-sorting and structuring just kill the AI's creativity? I mean, if you label everything beforehand, can it still have those aha moments and make novel connections? Well, according to the CEO, Julius Adebayo, the answer is a big yes. They found that the model still shows what they call emergent capabilities. It discovers and understands new, complex ideas all on its own, like quantum computing, that nobody explicitly spoon-fed to it. Okay, this all sounds pretty incredible, right? A traceable, transparent AI that can still be creative. But with any big leap in engineering, there are always trade-offs. And in the world of AI, the biggest trade-off is almost always performance. And here's the number that matters. Right now, Stirling 8B performs at about 90% of the capability of other top models of a similar size. So it's powerful, for sure, but it's not quite as powerful as the black box models it's up against. And this right here brings us to the absolute core question of this whole thing. Is giving up that last 10% of raw power worth gaining 100% total transparency? For some things, like maybe writing a poem or a song, maybe not. But for a huge number of really critical industries, the answer is a loud, resounding yes. And this slide just nails why that trade-off is a no-brainer in so many cases. Think about it. In finance, you can actually prove a loan decision wasn't based on protected data like someone's race. In medicine, a doctor needs to know why the AI recommended a certain treatment. For scientists, the AI's logic is just as important as its final answer. And for all of us, it means we could finally build systems that block harmful or copyrighted content at the source, because for the first time, we know exactly where it's all coming from. So, what does this all mean for the future of AI? For years now, the whole industry has been in this frantic race to just build bigger and bigger models, counting parameters in the billions, then trillions. But what Guide Labs is suggesting is that maybe we've been running the wrong race this whole time. This is the paradigm shift. This is the big idea. The race for sheer size might be coming to an end. The race for trust has just begun. This technology suggests that the next trillion-dollar AI company won't be the one that builds the biggest model, but the one that builds the first model we can actually, finally, understand and trust. So let's just wrap this up with the key takeaways. First and foremost, the black box problem isn't some unbreakable law of AI. It's an engineering challenge, and it looks like it has a real solution. Second, the future of AI isn't just about being the most powerful. It's about traceability and being able to interpret the results. This means that safety and transparency are moving from being nice-to-haves to being core essential features. And finally, for huge sectors of our economy, an AI we can trust is way, way more valuable than one that's just a little bit smarter. So I'll leave you with this to chew on. As we move into this next chapter of AI, how are we going to define smart? Is the smartest AI the biggest one with the most parameters, or is it the one we can actually work with, understand, and ultimately trust?